go for launch. So it was really a neat thing to watch happen.
Yeah, the voice loop communication was outstanding. They talked about, hey, we're about to start fueling in these minutes. We have this much time to make a decision if we think we're going to get there. The launch team, the SpaceX launch team was just outstanding on this.
Thank you so much for tag teaming the answer to that question. We do have someone joining us on the phone now, Chris Davenport of Washington Post. Chris, are you with us?
Yeah, I am. Thanks so much. Quick follow-up to Bill's question when you talk about this defect or the crack. Like, how big is it? Do you have a sense of the measurement? And Sarah, you said it was within the, I think, qualified limits. But what are those? Meaning, like, if you have a crack or a defect of 1 millimeter, it's okay, but 2 is a no-go. And I guess, and Steve, I'd like you to weigh in here as well, since you're tag teaming the answers. I just want to get a sense of your level of concern going through the countdown when you noticed this. Was this like a close call, or were you fairly confident early on that you felt like this was okay and you could go forward? Just want to gauge your level of concern. Thank you.
So to answer the question on the size, so we estimated this square acreage of this defect to be about 0.02 square inches, which is less than half of what we are required to qualify this system to. Holes or cracks or other defects, about 0.05 inches, I believe, is the qualification limit. Yeah, Steve, if you want to answer the second half of the question.
I would say when I first saw the picture of this defect, my experience told me it would be acceptable to fly based on where it was. Again, it was on the lee side of the vehicle. It was a very small defect. It was in an RTV seal, which is a room temperature vulcanized material. It can take high temperature, and then when it sees temperature, it kind of melts over. So that was my initial intuition, is that an engineering judgment is this would probably be okay based on my, also it was on the lee side of the vehicle, which doesn't see the high heating, in an area where we know the flow pattern really well. But I don't say anything at that point, right? I let the team go work through it and see what conclusions that the SpaceX TPS experts and the NASA TP experts come to. They worked through it over a number of minutes, chatted back and forth, went back and looked at the qualification. This particular seal has a bond verification, so when you install that seal, they pull on it to make sure it's rigidly attached, and then beneath it there's another secondary pressure seal, and then they talked about could you get any flow down, would there be any potential to get any flow inside any areas, if so, what would that mean, is there any pressure source to draw flow in? So I listened to the whole conversation, and based on the way that the engineering team went about it, and also looked at other vehicles, did they see any charring in this area, what's the heating like on previous reentries, and then also the abort cases, should we get into one of those. And so I was able to get comfortable, and our team was able to get comfortable that this was a defect that we could go fly.
Thank you so much for answering that. All right, we'll come back to the room now for any follow-up questions. We have one in the back there. Just give us a moment. It might take us a second to get you a mic. He's on the camera in the very back. There we go.
Transit to the International Space Station. They are now closing in on their 28-hour journey following a launch on Sunday, March 3rd at 9:53 p.m. Central, 10:53 p.m. Eastern. We are currently tracking a docking of about 1:40 a.m. Central, 2:40 a.m. Eastern, early on Tuesday, March 5th. Just a few minutes ago, the Dragon vehicle completed a out-of-plane burn, and it was a good burn. The vehicle is now just over 27,000 meters away from the space station and closing in at a rate of 4.5 meters per second.
Days, which is really exciting, but it gives us the flexibility that if there's ever a traffic conflict on 39A and 2 missions have to launch at the same time and one of them's a Dragon, now we can move over to LC-40 and prioritize both of those missions. So super exciting to have 2 pads. Emergency egress system is very similar to the slide wire baskets that were heritage NASA design over on 39A, which we use. The idea is you want to get people away from the top of the tower, both the pad closeout crew and the crew themselves, as quickly as possible. And so the primary egress route for most emergencies, well, let me back up. At one point, as soon as the rocket begins to be fueled, the primary mode of egress is actually the spacecraft itself, which can carry the crew away to safety. Before that, there's a couple of other different types of emergencies that could happen on the pad that we want to protect for. And we have an elevator that's the primary. It's a very unique elevator, fire safe, lots of unique launch pad related safety features on it is the primary mode of egress. And then we have similar to the slide wire baskets, another kind of chute escape system on you send a stretcher down this, essentially a slide. You may see some test subjects from the qualification campaign on this panel. And we completed all the required, completed all the required configurations. We looked at in a spacesuit, what if the spacesuit is a little bit wet because of a fire response up on the pad? And so, that was the last piece of the system to come together. It's checked out now. I think also this week we got the final external approvals as well. So I hope we get to fly a Dragon soon on off of 40.
And a couple of things that the chute system that Sarah talked about is kind of a system that's used in a lot of industrial applications. A lot of different buildings use a similar kind of system. So it is a very simple system that the company that SpaceX worked with has installed. We were out there looking at it the other day, and it's a very simple system, simple to use. And as Sarah said, we had NASA fire crash experts using that system in addition to some of the CAPE fire experts going down that with our ground and mission support personnel, and also health and medical engineering team out there doing about 3 or 4 hours of testing. And everybody that has used that system says it's really safe, really easy to use. So it's a pretty innovative solution, and we think it's going to be really good for crewed missions down the road.
Great, thanks so much, Sarah and Steve. All right, back to the room. We have another in the center aisle right here.
Hi. Yeah, this is for Joel. In the last couple of days, we received a report about the status of Zvezda, looking at the leak rate that has increased on the Russian segment. This is kind of a two-part question. So, how much risk is there to Crew right now? Actually, three-part question. How much risk is there to Crew right now? Are the hatches sealed in that area? And what is kind of the action plan for going forward with that leak and increased leak rate? Thank you.
Sure. Right now the hatch is closed, and it's been closed since, I believe, middle last week or so. The plan is to keep that hatch closed until early April. Right now we're working with our Roscosmos colleagues on what is the plan. When you go into that area and open that hatch, how long do you stay there? Do you keep the hatch open at night, et cetera, et cetera? But we got a little time to go work that. But right now there's not a safety issue with the crew. That hatch is closed. When that hatch is open, the leak rate is about 2 pounds a day, a little over 2 pounds a day.
Thank you, Joel. Back to the room for additional questions. Another in the front row here.
I don't come often, so I'll take advantage. What's the process like for adapting to life on the International Space Station?
So the first week when the crew members are on board, we give them an hour of kind of relaxed time or adaptation time. We don't fully schedule them that first week. These 5 days, they'll be handing over with Crew 7. So Crew 7 will be telling, hey, here's the lessons learned. Hey, when the ground calls up and says you have to do this activity, here's some of the things we learned to make it easier or more time efficient. And so that first week is adapting to space. So you'll have a fluid shift of the body, and so that takes a couple days or so. But getting with the Crew 7, understanding the lessons learned, and then, like I said, that first week we schedule them an hour less, and then after that, we put them to work.
All right. Thank you, Joel. Any other questions here in the room? All right, seeing no hands raised, I'll take that as a cue for us to wrap things up. I know that it is early or late, depending on where you're watching from. So I want to thank the media for joining us here in the room, and especially those of you that also ask questions over the phone as well. I want to thank our panel, Steve, Joel, and Sarah, for being up late to take our questions. Before we let you go, we do want to remind you about docking. So Crew-8 is well on its way, and docking to the International Space Station is set for Tuesday. That is March 5th at approximately 3 a.m., and coverage is scheduled to begin at 1 a.m. Eastern on Tuesday morning, and that will be on NASA TV. So thank you again for everybody that joined us today, and until next time, go NASA, go SpaceX, and go Crew-8. Good morning and welcome to NASA's Kennedy Space Center in Florida. I'm Jasmine Hopkins, and you are watching the post-launch news conference for NASA and SpaceX's Crew-8 mission. At 10:53 p.m. Eastern last night, that was Sunday, March 3rd, NASA astronauts and one cosmonaut lifted off for the International Space Station. The crew contained Michael Barrett, Matthew Dominic, and Jeanette Epps, along with Roscosmos cosmonaut Alexander Gurbenkian, and they are now on their way to the International Space Station. Joining us tonight is a group of distinguished experts who are going to talk to us about that mission and what is in store for the crew. So starting from my left, we have Steve Stitch, manager of NASA's Commercial Crew Program, followed by Joel Maltabano, manager for the International Space Station Program, and finally Sarah Walker, director of Dragon Mission Management from SpaceX. We appreciate them being here with us tonight, and this panel will be taking questions from the media in the room and over the phone. But before we get to those questions, we'll give them each a moment for opening remarks. So, Steve Stitch, we'll start with you.
Thank you, and good morning, good evening to everybody. It's awesome to be here tonight after a great launch about an hour and 20 minutes or so ago. I really would like to congratulate the entire NASA SpaceX team, along with their international partners, Roscosmos, ESA, and the Japanese Aerospace Agency as well. Great to be part of this team. I think, launches like this really illustrate what it takes to do human spaceflight and to take it one step at a time, like we have all the way from the FRR, agency FRR that we had last Sunday. We took our time one step at a time each day. We fought some pretty challenging weather, I would say, over the last few days. We stood down a couple of days, 2 opportunities on March the 1st due to winds in the staging area. We made a really good try at it last night. We thought we might be able to squeeze in an opportunity, but the weather wasn't good, and so we stood down and scrubbed that launch. And then tonight, the weather held, and we had good weather in the staging area, good weather for the launch site, and we were able to launch successfully. It was awesome to listen to the crew and the excitement. You heard Matt Dominic make several calls to the ground relative to the abort boundaries going up the hill, and so it was great to hear Matt's voice. You could tell that they were really excited on their way to the International Space Station and on orbit. The vehicle is doing great. Before we came over here, we separated from the Falcon 9. That all went really well. We opened the nose cone, and that went just fine. Checked out the forward bulkhead Draco thrusters, which are the thrusters that we do the big burns with. Those all worked fine. Did one phasing burn a little while ago. It was about a 45 meter per second burn, and that went well. The crew will get a little off-duty time starting about 2 a.m. here in the morning, and then setting us up for the next big phasing burn, which will happen around 4:14 p.m. tomorrow. And then the rest of the sequence goes early Tuesday morning at 1:34 a.m. Eastern time. We'll do what's called the approach initiation burn. That sets us up for the final phase for the rendezvous and docking, and then we should dock around 3 a.m. Eastern on Tuesday morning, early in the morning. So right now, Dragon's doing well. We're excited to have Endeavour on orbit with its 5th flight. And then, we're going to set up for Crew-7 return. Once we get docked, we'll work on the Crew-7 return. The earliest return would be probably a week from today, around March 11th or so. The countdown was really smooth. We had, one item that we worked, and Sarah Walker will talk a little bit more about that, an area of the TPS around the hatch seal on the upper part that we had a little imperfection that we wanted to take extra time and make sure it was good, and Sarah will talk about that. So once again, I'd like to thank the entire team, thank our NASA SpaceX team and all the international partners, the International Space Station Program, the Flight Ops Director at NASA, and I'll turn it over to Joel Montalbano.
Thank you, Steve, and what an outstanding launch. You know, you heard how excited the crew was. We were just excited in the Launch Control Center, as well as all the control centers across the globe watching this mission. Just outstanding. Steve mentioned that we're setting up for a docking around 3 a.m., and then we'll have hatch, March 5th, we'll have hatch opening about 2 hours after that. And this crew will do a handover with Crew-7 about 5 dock days. And so that sets us up, as Steve was saying, no earlier than about March 11th. But we'll be watching weather, and we'll wait for the best opportunity to undock and land Crew-7. Shortly after Crew-7, the focus will be to SpaceX 30, the next Drago cargo mission to the International Space Station, right now targeting the middle of the month for that. And then following that mission, we'll have a Soyuz launch on March 21st, and then a Soyuz landing on April 2nd. Crew-8 will dock to the forward port of the International Space Station. They will stay docked until late August, and we have about 250 experiments in science and research, technology development, as well as commercialization of low Earth orbit. With that, a huge thanks to all the NASA colleagues who make these missions work, to SpaceX, to our international partners. Just a true cooperation across the globe. With that, I'll hand it over to Sarah.
Yeah, thanks, Joel. Yeah, it's been a great week down here at SpaceX and Kennedy Space Center. I'm glad the clouds finally parted for tonight's launch. And we're proud to have just launched, as everyone has said, Crew-8 from Launch Complex 39A. It marks SpaceX's 13th human spaceflight mission. And I was thinking about what to share with you guys today. I was struck by this being the 5th flight of this Dragon spacecraft. It launched on the 5th anniversary weekend of Demo 1, which was the inaugural Dragon crew flight. And it's docking on March 5th, a couple days here. And its crew marks the 50th crew member that SpaceX has sent to space. So in just the handful of years since Bob and Doug flew this very spacecraft, actually, on Demo 2. So this spacecraft, which its first crew named Endeavour, has now flown the Demo 2, Crew-2, AX-1, Crew-6, and now Crew-8 crews to space for a total of 466 days on orbit and counting. So I'm glad to report we've inserted into a nominal orbit tonight. I think Steve mentioned also Dragon and the crew are on their way to the space station. We anticipate arrival around 3 a.m. Tuesday morning, Eastern Time. It was an extremely quiet countdown on console tonight, one of the quietest that I've ever been a part of. But Steve mentioned the area of interest that we worked was around 45 minutes. The engineers who are doing the closeout photo check, once we close the hatch, they take detailed photos of the perimeter of the hatch and that final seal. And as they were doing those reviews, they noticed an area of interest on kind of the upper section of the RTV, which is kind of a top coating on the hatch seal, that they wanted us to take a look at. So we looked at the photos. Eventually it was determined that the size of the defect or separation of that RTV seal was within the qualified limits of the design. So that was ultimately the flight rationale that cleared us for launch. There were a couple of other areas of conservatism that further, I guess, increased the confidence. This is one of multiple redundant seals in this area. It's kind of a top coating over the pressure seal, which is then over the main seal for the hatch. There's also a very low heating region for the vehicle. And actually this material expands under heating. And so we expect that actually a defect of this size would self-heal during the launch process. So, but we spent some time consulting with NASA experts and the SpaceX experts back in Hawthorne, and ultimately decided we felt comfortable and confident safely proceeding into today's launch. So it's amazing to think that SpaceX has now launched 45 times to the ISS. We've launched enough together that I think we can be really proud of what we've accomplished, but I think not enough times to take for granted just how much it takes to get this right every single time. A lot goes into that, and we know what the stakes are, and I'm really proud of the team and the clean execution that I saw tonight on console. I think there's an incredible team of engineers at both NASA and SpaceX over the last many months that have been laser focused on leaving no stone unturned as we stepped methodically.
We're approximately 30 minutes ahead of schedule, so we'll be pulling some events to the left by 15 minutes. Let me know when you are ready to copy the updated timeline.
Good morning, Tremaine. We're ready to copy.
Good morning, Matt. All right, so first up, the approach OOP burn that has already been completed and was nominal. We are then going to target our PMC at 5:15, followed by suit donning immediately afterwards, notionally 5:30. Approach initiation will be 6:03 and estimated docking 7:28. How copy?
Right, we copy PMC 5:15, suit on 5:30, approach initiation 0603, and docking 7:28.
That is a good readback.
We will get after it, sir. Thank you so much.
The leak on ISS?
Yeah, thanks for the question. Yeah, the Starliner launch is extremely important to the Commercial Crew program, to the ISS program, and to NASA. I was just over at the Boeing facility, I guess it's Sunday last week, on Friday. That spacecraft has been rolled into an area where they do the propellant load, and so it's sitting there ready for propellant load. What we've been doing is kind of watching how we progress with the Crew-8 launch, and then the CRS-30 mission, and then we'll decide when to load propellant. But that mission is on track. Right now we're looking at kind of the end of April. It really is based on the sequence of events that we talked about before. We have to launch Crew-8, bring Crew-7 home, then launch the cargo mission, which Sarah talked about is already
To earliest docking time.
We need to move up to the Zenith port, to the forward port. So right now, the vehicle's ready. We're closing out the certification. I would say the thing that's pacing when we go fly is really this complicated, sort of traffic management. And I'll let Joel talk about the leak.
Yeah, I'll just have one thing on Starliner. It's very important for the agency to have two providers that are delivering crew to the International Space Station. And so, we're excited to have Boeing and looking forward to having these missions where we have one SpaceX and one Boeing mission every year. On the PRK leak, no real changes since the last time we talked. Right now that hatch is closed, and the hatch is scheduled to be closed until early April.
All right, thank you. We have some questions here in the very front.
Hi, everyone. I'm Andrew Donovan from News Channel 9 in Syracuse, New York. We traveled here to tell the story of Jeanette Epps.
Of Crew-8's journey to the International Space Station following a launch late on Sunday evening. We currently have a tally-ho from station of Dragon approaching the International Space Station, which will be their final destination and their home for the next 6 months. We are now looking at a docking of about 1:28 a.m. Central with an AI burn at 1:03 a.m. Central. Teams will be polling for a go, no-go for the AI burn in just about 28 minutes from now. Dragon is currently just under 22,000 meters away from the space station and closing in at a rate of 4.3 meters per second.
And so they really enjoy it. They love being, they will love being in space. They'll love being on the International Space Station. So to me, it's exciting every time we have a rookie on board.
Great, thanks so much. We have a question right there.
Bill Harwood, CBS, and this is for Steve. About the SEAL thing, does NASA have the authority to disagree with SpaceX in a case like this and stop a launch if you wanted to, number one, or is this a SpaceX call, period, on a system as subtle as this, and they're the ones that have the data? That's number one. And number two, what is your approach management style? Because when a problem like this crops up with just a few minutes before launch, I mean, no matter how you look at it, there's a lot of pressure on you to make a decision quickly, because you were on the verge of delaying fueling, which would scrub the launch if you didn't get that done, and then you're down to 10 minutes to launch before you resolve it. So just from a management standpoint, how do you guys deal with the last minute thing? You're smiling, Joel, because I mean, anybody that watches one of this is going like, how do we know that, you guys are really doing the right thing, to put it? I mean, I know you are, but it raises that question when you're faced with a decision like this in the last minutes of the countdown.
Yeah, relative to the first part of your, good question, Bill. Relative to the first part of your question, absolutely, NASA has the authority to stop the launch, and if we see a course of action that we don't necessarily think is right. I mean, a few flights ago, Crew-8, right, when we had the T-tab incident where looked like it wasn't filling, we couldn't get ourselves convinced that we would have a good start in the engine. NASA and SpaceX worked together, and we decided that it wasn't a good day to go fly. So we actually have that authority at any point in time if we see something that we don't like. And SpaceX polls us multiple times in the countdown, polls us as late, in this case, as 5 minutes prior to launch. NASA, are you still ready? Are you still ready to proceed? For this particular case, I would say have a lot of experience I do from Space Shuttle. And this was a thermal seal on what we would call the leeward side of the vehicle, right? This is the side of the vehicle that doesn't see the highest heating. So we looked at this particular defect in the seal. It's a thermal seal. It's made of RTV, as Sarah says. So that RTV generally will heat up during entry and seal any kind of anomaly. The engineers went back and looked at the heating in this particular area, the top part of this hatch seal, and that heating wasn't anything that would be of concern with this size defect. We also went and looked, we've flown a lot of, I would say, experiments in the TPS on cargo flights where we put some defects in the TPS, and we've looked at those on this side of the vehicle. We looked at that data in that time frame and said, hey, based on much bigger sizes of defects that we did as an experiment, that this would be no concern. We had our TPS experts involved, a couple of guys that I have utmost confidence in from the Space Shuttle program. I listened to the whole conversation that they had back and forth with SpaceX and their rationale for proceeding to launch. And I thought that they had exactly the right rationale for this size little imperfection in the seal. It really doesn't, the hatch seal per se, the pressure part of the hatch seal is way underneath the vehicle, right? So this is in an area of a TPS seal. And so, they had great rationale. Our guys agreed with SpaceX. They came to the really good conclusion. You're right, the clock is counting, but we could have backed out at any point on down inside of even a minute. So.
Is this something that was caused when the hatch was closed, or was this something that was there all along, they just didn't spot it before? Or?
Yeah, it's part of the hatch closure process. So it's normal that around an hour before launch, we're reviewing all the photos of that final operation, and then an engineer flagged it. Yeah, and I would just echo what Steve said. It was really a privilege to listen on the nets, the kind of methodical nature that the teams worked through. Our experts back in Hawthorne and the NASA experts back in Houston were immediately on the phone and on the nets together, working together. And then there's also NASA operators here with us in launch control. And one thing that I thought was really neat is once our vice president of Dragon Engineering got on the nets and explained his flight rationale and why he and his NASA counterparts were comfortable proceeding, the NASA operations manager said, you come to all the same conclusions that our team here in the room had just independently come up with you. And so then we corroborated one another and agreed to go for launch. So it was really a neat thing to watch happen.
Yeah, the voice loop communication was outstanding. They talked about, hey, we're about to start fueling in these minutes. We have this much time to make a decision if we think we're going to get there. The launch team, the SpaceX launch team was just outstanding on this.
Thank you so much for tag teaming the answer to that question. We do have someone joining us on the phone now, Chris Davenport of Washington Post. Chris, are you with us?
Yeah, I am. Thanks so much. Quick follow-up to Bill's question when you talk about this defect or the crack. Like, how big is it? Do you have a sense of the measurement? And Sarah, you said it was within the, I think, qualified limits. But what are those? Meaning, like, if you have a crack or a defect of 1 millimeter, it's okay, but 2 is a no-go. And I guess, and Steve, I'd like you to weigh in here as well, since you're tag teaming the answers. I just want to get a sense of your level of concern going through the countdown when you noticed this. Was this like a close call, or were you fairly confident early on that you felt like this was okay and you could go forward? Just want to gauge your level of concern. Thank you.
So to answer the question on the size, so we estimated this square acreage of this defect to be about 0.02 square inches, which is less than half of what we are required to qualify this system to. Holes or cracks or other defects, about 0.05 inches, I believe, is the qualification limit. Steve, if you want to answer the second half of the question.
I would say when I first saw the picture of this defect, my experience told me it would be acceptable to fly based on where it was. Again, it was on the lee side of the vehicle. It was a very small defect. It was in an RTV seal, which is a room temperature vulcanized material. It can take high temperature, and then when it sees temperature, it kind of melts over. So that was my initial intuition, is that an engineering judgment is this would probably be okay based on my. Also, it was on the lee side of the vehicle, which doesn't see the high heating, in an area where we know the flow pattern really well. But I don't say anything at that point, right? I let the team go work through it and see what conclusions that the SpaceX TPS experts and the NASA TP experts come to. They worked through it over a number of minutes, chatted back and forth, went back and looked at the qualification. This particular seal has a bond verification, so when you install that seal, they pull on it to make sure it's rigidly attached. And then beneath it, there's another secondary pressure seal. And then they talked about, could you get any flow down? Would there be any potential to get any flow inside any areas? If so, what would that mean? Is there any pressure source to draw flow in? So I listened to the whole conversation, and based on the way that the engineering team went about it, and also looked at other vehicles, did they see any charring in this area? What's the heating like on previous reentries? And then also the abort cases, should we get into one of those? And so I was able to get comfortable, and our team was able to get comfortable that this was a defect that we could go fly.
Thank you so much for answering that. All right, we'll come back to the room now for any follow-up questions. We have one in the back there. Just give us a moment. It might take us a second to get you a mic. He's on the camera in the very back. There we go.
Yeah, thanks. Hi, Will Robinson-Smith with Spaceflight Now. Question for Sarah. Since you all have mentioned the CRS-30 mission, which is set to fly off Pad 40, can you give us an update on how qualification for that is going? And particularly, we saw the emergency escape system being tested with what looks like some type of slide mechanism. Can you explain exactly what that is, how it works, and will you test that with humans before it's human rated? Thanks.
Yes, and that qualification is complete, which is really exciting. Yeah, so Pad 40, you guys are all aware that we've been trying to build up redundant Dragon capability on our 2 neighboring pads, which is really exciting. Remember, Pad 40 is our high-rate pad, and so it's most efficiently used for satellite launches. I think we've gotten the launch-to-launch turned down to just a couple of days, which is really exciting. But it gives us the flexibility that if there's ever a traffic conflict on 39A and 2 missions have to launch at the same time and one of them's a Dragon, now we can move over to LC-40 and prioritize both of those missions. So super exciting to have 2 pads. The emergency egress system is very similar to the slide wire baskets that were heritage NASA design over on 39A, which we use. The idea is you want to get people away from the top of the tower, both the pad closeout crew and the crew themselves, as quickly as possible. And